problems based on self-inductance and mutual inductance. Take down two circular coils two circular coils, one of radius r and the other of radius capital R. So for smaller coil, radius is smaller, the larger one capital R. Are placed coaxially. What do you mean by coaxially? That is, they have got the center, common center. So O is the center. You have put one circular coil, another circular coil. Are you able to understand this? They are placed coaxially with their centers coinciding. So they have the common center. So they are coaxially placed. You know, R is much greater than the radius of the inner coil. Obtain an expression obtain an expression for the mutual inductance of this arrangement. So you can draw this coil coaxially placed. So they've got the common center. Let me call it C1, C2. The radius of C1 is capital R. The radius of smaller coil C2 is smaller. Now, what is the magnetic field B1? The magnetic field B1, it depends on the current passing through that and twice the radius of the coil, and then you got the permeability mu naught. Okay. And let me say the current passing through the first coil B1. So this is the magnetic field created, because you know very well when current is passing through one coil, magnetic field is created. So this magnetic field created in the first coil is proportional to I1 divided by 2R. It means mu naught I into divided by 2R. Now let us analyze the flux linked. Flux linked with coil 2, C2. It depends on what the flux is represented by phi, and this is phi 2. It depends on the magnetic field. Is it not created by the first coil? So that is equal to V1 into the area enveloped by the second coil, that is A2. Okay. So you can replace this B1 by this equation. So that is B1, instead of B1 you can put mu naught I1 divided by 2R into A2. Okay. And what is this A2 area of the second coil? That is pi r square. Is it not? So what is A2? A2 is the area enveloped by the second coil, that is pi r2 square. So you can replace this as what? That is mu naught I1 divided by 2 capital R into pi r square. Why pi r2? What is the area of a circle? What is the area of a circle? So pi r square. pi r2 square, pi r2 square. Because small, let us not call it r2. This I have simply put small r. So small r square. Now, our objective is to get the M. What is M? Mutual inductance is equal to phi 2 divided by I1. Because phi 2 is equal to M into I1. Is it not? That equation you know. The magnetic flux is equal to M into I1. How much current is passing through the first coil? Based on the magnetic flux is created. Okay. That depends on the current passing through the first coil. And M is the proportionality constant. So here M is equal to phi 2 by I. So that is why I brought like this. And you can replace this phi 2 by this equation. Okay. So it becomes what M is equal to, instead of phi 2 you can write mu naught I1 divided by 2R into pi r square. I have completely written phi 2 divided by I1. So the I1 can be cancelled. Therefore, M is equal to what? Mu naught divided by 2R into pi r square. So this is the expression they wanted. Okay. Now let us move to the second question. The current in a circuit falls steadily from 5 ampere to 5.0 ampere to 0.0 ampere in 100 milliseconds. If an average EMF of 200 volt is induced, calculate the self-inductance of the circuit. Now, solution. What are given? Induced EMF is given. How much? 200 volt. And then L is asked. Then there is a steady what? Decrease in the current. Okay. From how many ampere to how many ampere? 5 ampere to 0 ampere. So the difference is 5 only. Okay. So 5 ampere. So actually final minus initial. So it becomes minus 5. Okay. This is final. This is initial. Difference is final minus initial. That indicates the drop here, and that is given by the sign negative. So it is minus 5 divided by, it is said 100 millisecond. So this is di. And what about time dt? It is given as 100 millisecond. It means 100 into 10 power minus 3 second. That is 10 squared into 10 power minus 3 second. That is 10 power minus 1 second. So this is dt. Clear? Now L is asked. What is the formula? induced EMF is equal to, what is that? Minus L di by dt, right? This is the formula. Okay. Now we are interested to find out L. So L is equal to what? Minus E divided by di divided by dt, right? So L is equal to minus E. How much? That is 200. Okay. Divided by 5. Listen to me carefully. 5 divided by, because di by dt. So di is minus 5. So put minus 5. Divided by dt means 10 power minus 1. Okay. So it is now reciprocated, and minus 200. You have to be very careful. I am just reciprocating. I should not change the sign. If it is 1 by x means when it goes here, x. So it becomes what? 10 power minus 1 only divided by minus 5. Is there any doubt here? Normally what happens when you take anything to the power, it gives the opposite. But this is in the denominator of denominator. Okay. So it is something like, for example, minus 200 divided by a by b. It means what? Or you can put even like this also. For L is equal to minus E divided by di by dt. That is equal to what? Minus E divided by di. This dt goes up. I hope now you should be able to understand. If it is in the numerator, for example, if it is a 200 divided by 10 power minus 1, when it goes here, it becomes 200 into 10 power plus 1. But it is not in the, it is this itself in another fraction. Okay, so you have to consider. So in that case, 200 divided by minus 5 divided by 10 power minus 1 means 200 into reciprocate. So 10 power minus 1 divided by minus 5. Do you understand this? Okay, so you have to be very careful. Then you can call it minus of minus plus. And this is 200 means 20 divided by 5 is equal to 4. Okay, so 4 Henry is the correct answer. Pranav, were you able to understand this? Right. Now let us move to the next question. An average induced EMF of 0.4 volt appears in a coil. When current is changed from 10 ampere to 10 ampere in one direction, 10 ampere in one direction to 10 ampere in opposite direction. So it goes like this. Here 10 ampere, it goes in this way 10 ampere. Or you can understand? In opposite direction. And that too it happens in 4 seconds. Not 4 seconds, 0.4 seconds. Find the coefficient of self-inductance of the coil. Now, what is asked here? L is asked. What is the formula for L? L is equal to E modulus divided by di by dt, the same one. Okay. So now L is equal to zero point 0.4, that is this one, divided by what is the change in the current? Change in the current in the opposite direction means first 10 ampere, okay, and then change in the current means minus 10. So it means 20 ampere, okay. You should not put 10 minus 10 0, no, it is in the opposite direction. So 10 minus of minus, so 20. So you have to put 20 ampere and bring the dt above. In how many seconds? zero point 0.4 seconds. That's all. So what you can do? Multiply by 100 so that it becomes a 4 into 4 divided by 20. That will be easy for us to calculate. And this is 100 by 100. Okay. So here you have got 100. And this has been multiplied. So 4 into 4. Are you able to understand? And this is 5 times. Okay. Then multiply by 2 by 2. So it means 8 divided by 10 cube. It means 8 into 10 power minus 3. Okay, Henry. So this is L. Next question. Show that the magnetic energy required to build up the current I in the coil of self-inductance L is given by half Li square. So the magnetic energy with the current I is equal to half Li square. It means magnetic energy is given by UB. You have to show UB is equal to 1 by 2 L I naught square. Now let me consider a coil like this, and its inductance is L, connected to a source of varying EMF where it is connected to some varying EMF. And because of the changing current, what happens here? The induced EMF will be produced due to self-induction, and this induced EMF will definitely oppose the change in current. So let us calculate the work done in stored magnetic potential energy in the coil. So power, take down, power P. It is nothing but rate of doing the work. So dW divided by dt. Okay. What do you mean by rate of doing the work? How fast the work is being done. That is also power. Okay. And this is also equal to the induced EMF into I. So here I take the magnitude of the induced EMF. Therefore, I can put the dW by dt is equal to, and E, I can have this equation, E is equal to what? That is L di by dt, right? So I can replace this. So instead of E, I can put L into di by dt into L, into I. Okay. So let us rearrange this. And here you have dt is cancelled. So let me consider dw only. So L into I into di. Now let us integrate. So on integration, we get w. dw is equal to w. And here I am integrating between the limits 0 and I0. So in that case, it becomes what? That is, you have got already Li. On integration of dA, it becomes again what? What is that? I1A. Integration of a dx is equal to x1A. So I, between the limits what? 0 to I naught. Okay, take out 0 to I naught. So it means, and you have got this, what I call, that is, you have got already I, and this is I naught. Is it not? I'm sorry. So this is not a constant. It should be IDA, right? So IDA means what? X dx on integration x power 1 plus 1 divided by 1 plus 1. So it becomes I squared divided by 2, right? Therefore, this is L I squared. Instead of I squared, I can put I naught squared divided by 2 minus, you can substitute 0, so you can ignore it. So L I naught squared divided by 2. That is nothing but your work, which is nothing but your potential energy, magnetic energy. Therefore, the magnetic energy here is shown that 1 by 2 L I naught squared. Hence the proof. Next question. The magnetic flux linked, the magnetic flux linked with a larger circular coil of radius r is 0.5 into 10 cube 10 power minus 3 Weber. When passing a current of 0.5 ampere, that flows through a small neighboring coil. So large coil, neighboring coil, neighboring small coil. This is large coil of radius r. Calculate the coefficients of mutual inductance. Calculate the coefficients of mutual inductance. That is, M is asked for the pair of coil, for the given pair of coil. So you have got one coil like this, and you have got another small coil. Let me have only one coil. So nearby, I have got one small coil. So these are the two coils placed nearby. So the radius of this one is capital R, the radius of this one is smaller, one is smaller. and the flux here is phi is equal to zero point 0.5 into 10 power minus 3 Weber, and the current passing through this coil is that is equal to zero point 0.5 ampere. Now, what is the mutual inductance? The coefficient of mutual inductance is what is M. So that is the question. Now, see, in fact, here we are checking the magnetic flux created in the second coil. That is B mu B2, magnetic flux in the second coil, is equal to, that is given, zero point 0.5 into 10 power minus 3 Weber. This is the magnetic flux created because of the current carried by the first coil. How much? That is 0.5 ampere, right? So this is I1. So what they have asked, you had to calculate the, yeah, right? So we know the phi B2, that is phi 2, is equal to M into I1. Okay. And what is M? That is nothing but phi B2 divided by I1. So that is equal to, what is phi B2? This one. 0.5 into 10 power minus 3 divided by, and what is I1? 0.5 ampere. So you can cancel. So it is a 10 power minus 3. Okay. Henry unit is very important. So the correct answer is 10 power minus 3. It means 0.001 Henry. Sometimes it can be called 1 millihenry. Small m, capital H. Now let us move to the last part of this lesson.